In this video, we'll learn about how to display a circular linked list. So we already know how to display a linear linked list. So the procedure will be same definitely. But the difference is in linear linked list, last node was having null, so we were stopping there. But now they are circular. So if you start from this node, then if you go on accessing, you may be reaching back on the same node. So here we have to stop when you are reaching on the starting point again. Then the list has finished. So let us see how we can do this one. So I'll write on the code. So I will write on a function for displaying a circular linked list. Display function. It takes a pointer to head node. P is a pointer to head node. So when we call this function, we should call it like this. Display and pass the pointer head. So if you pass the pointer head, then this function is called. Let us write the function. So P is here. Okay, P is here. So let us see the procedure how to display it, and simultaneously I will write down instructions here. I have a pointer P pointing on head node. So let us say P is pointing on head node. Print this data. So printf %id P's data. So P's data is printed. Then move P to next node. P assign P is next. So P will move to next node. Okay, P will move to next node. Now next what I should do? Repeat the same thing. Print and move next. Print and move next. So okay, I will write down it in a loop, while loop. So what should be the condition here? Let us see. This will print and move next. So print and move next. So suppose P is here. Print this and move next. Print this and move next. Now print this and move next. We are back on head. So now we should not print. Now we should not print. We should stop when it has reached head once again. So what condition I should write? So I should continue when P is not equal to head, while P is not equal to head. So while P is not equal to head. If I write this condition, the problem is first time only P is equal to head. So it will not enter at all. It will not print anything. So this cannot be done using while loop then. This cannot be done using while loop. I have to do this using do while loop. Do while loop. Because first time only P is equal to head, so it will not enter in. We are talking about second time when it is coming on head, then we should stop. So better use do while loop. So first of all, let it print and move next, then we will see if it is coming back on head. So this has to be written as do while. Do while P not equal to head. So this do while will work perfectly. So this function is for printing a circular linked list. Now let me write down a display function using recursion. It is little difficult. It's not so easy like the other recursions we have seen. So let me write the function and explain you. A display function, I am going to make it recursive. This is taking parameter node. So let us call it by passing head. Head node, that is the beginning node of a linked list. Now here, in the previous recursion for a linear linked list, we were writing the condition if P is not equal to null. This was the condition. But we cannot use this condition. We never get this condition satisfied because there is no null here. Then what I have to say? P not equal to head, I should say. Not equal to head, if I say, then already it is head. First time when you pass, P will be on this head and it will never enter inside. Then what I mean to say here is that first time P and head will be same. And when the P moves around all the nodes, then again back on the same node, again it will be on same node. So second time, if it is coming for the second time, then stop. So how to know this is the first time or second time? So for that, I have to take some variable flag. So let us take a flag. So here I will declare a variable that is integer flag, and this flag value is 0. So if flag value is 0 means this is first time. If flag value is 1 means second time. So by this 0 and 1 value we can identify whether this is the first time that P and head are on the same node or this is the second time. So let us write down the code. Let us write down this. If P is not equal to head or flag equal to 0. So this will continue. See, first time P is equal to head. So this is false. But flag is 0. Yes, this is true. The next I will print it. P's data is printed and call itself again. Call itself again for the next node. That's all. But once it has print entered inside, then flag should become 1. So I should make flag as 1. So here inside I will make flag as 1. Let us trace this one. Let us trace this. First time P is here. P not equal to head? No, it's equal. False. But flag is 0. Yes, flag is 0. Then enter inside. Make flag as 1. So flag will become now 1. Flag will become 1. Then print the value and call itself for the next node. So P will be called upon next node. Now this time P not equal to head. Yes, P is not equal to head. This condition is true. Or flag equals to 0. No, flag is equal to 1. So this is false. This is true. But OR condition is used here. So if any one is true, it is true. So this is true. So it will continue. So it will print this one, then this one, then this one, then this one. Then again it comes here. So like it is calling itself again and again. Now this time P not equal to head. No, it's equal to head. False. Flag equals to 0. No, flag is equals to 1. So both the conditions are false. So it will come out of this one. And it will not enter inside. So when it is exiting, I should make flag as again 0 and exit. Now one more thing is missing. See, this flag variable, for every call a new variable will be created. Right? Inside the stack activation record, two variables are used by this function, node pointer and flag. So every time two new variable will be created inside the stack. Already you know how stack works, so I'm not going to trace this one now. So every time flag becomes 0. So it's not the same flag. What I want is for all recursive calls, there should be only one flag. Then I should declare the flag outside as a global variable. Or if I want to keep it only inside this function, then I should make it as static variable. So static variable will be just like a global variable only, but limited to a function. It is accessible only inside a function. So there will be just one single copy of flag variable for all the function calls. So how many times a function will call itself? 1, 2, 3, 4, 5, then again here 6. So 6 calls it will make, and at the 6th call make the flag as 0 and terminates. So finally, for writing a recursive function upon linked list, we have to use static variables. So this static variable will help us know whether this is for the first time P and head are same, or is it the second time they are same. So I am using flag for 0 and 1. That's it.